components in matrix. So the other way would be we could do the whole thing with the angle between them, but I don't know what the foggiest, and I wouldn't expect you to either. What the angle between those vectors is. As I said, there's no way to know short of doing your dot product or cross product. So matrix is the way to go.
Is there any way to do that matrix in your calculator? I mean, I know there's a matrix function, but I'll probably figure out how to put in a variable.
I haven't messed with fancy calculators in a very long time, so I'm not a calculator expert. Okay, so we're going to set up a matrix. We have I, J, K. There are A components here. We've got 5, -4, and 7. This is the I, J, K components of the A vector A. And then we have -3, -13, and 2 are the components of our vector B. And then going to rewrite the first two columns, I and J. So we got 5, -4, -3, -13. Okay. So now I'm going to take the determinant of this. So this right here, leaving off this is the formal way of writing a determinant. This is just a way of calculating it. So I'm going to take, my, they already used the red. So I'm going to take these products, add them, and then I'm going to take these products here and subtract them. And I know we already kind of did this on Friday. I just feel like it's like an example worth doing. Okay, so we have I, -4, and 2. So that gives us -8I. And all this is going to be, these are in meters, these are in newtons. So each one of these is going to be a Newton meter. Each and every term I write, the units be Newton meters. So I don't want to have to write Newton meters, I don't know, on the order of 10 times. So I'm just going to throw it on at the end, okay? I'm going to put some parentheses and throw Newton meters on it. So each one of these is Newton meters. So I have I times -4 times 2. Yeah, so we're multiplying these up. So it's this product. So you add the red ones and then subtract the blue ones. So this one's negative number, so this one becomes negative. So here we got J, 7, -3. So again, that becomes a minus. So minus 21 J. Then we got K, 5, -13. So -65 K. So much for addition, they all end up being negative. Each one had a negative terminant. So now we're going to subtract this off. So this has 2 negatives, which cancel out. So then we're going to end up with -12K right here. -3, -4, and K. This will swell out.
And you're still multiplying with those numbers?
Yep, all this is products. So I have my -3, my -4, and my K. I multiply those together, and I get 12K. Except we're supposed to minus the blue ones, so it's minus 12K. So minus 12K. What's my next one? What is it? -19. Yeah. So I got 7 and 13 multiplied together, -13, would be -91, but we're subtracting it, so we're subtracting a -91, which means we're adding 91. So plus 91 I, and then what's our next one? What is it? Yeah. 5 and 2 multiply it to be 10 from J, so it's -10J. And now, I promised I am going to throw units on the end of this and call this Newton meters. Okay. Okay, so now we can combine terms. So I'm going to start off with my i's here. So how much I do I have? Yeah, 83. 83I. Yep, so I got 21 here and 10 there with each negative, so it's negative 31. And then we got, yeah, negative 65, negative 12, so we have negative 77. Okay, and this is still all in meters. So this equals A cross B. So what this essentially means is if you took a lever arm, this lever arm, that long, it's going in that direction, and you apply this force to it, going in that direction, that magnitude, that's the torque as a result. The axis of the torque would be in this direction. Its magnitude would be, if you want to take magnitude, just square each of these and take the square root of the sum of the product, sum of the squares. Or Pythagorean so three terms. Is everybody this making sense as far as what this is and a physical quantity? Yeah, Joe.
So when you do crop product, are you always making a matrix?
You're not always making a matrix. If you don't know the angle between them, yeah, then you're probably making a matrix. Fortunately, we're going to get into this. Oftentimes, you do know them. Oftentimes, either they are perpendicular to each other, or is sort of working in a plane. There were a lot of problems, like what Carl was doing before, and we're going to be getting into it. The vectors are in a plane, and you know the angle between them. Because then you can do this up with the sign. And just using the right hand wheel for the direction it's going. Did that answer the question? Yeah. Okay. So, let me just throw this one in. I sort of missed this one when I was going over my sort of calculus reviews. I'm just going to stick to this. It's basically the product rule. I'm going to erase this. Okay, can you erase this? Okay, so we're going to take the derivative of the cross product. So, differentiation of the cross product. So we want to know, just usually with respect to time, so I'm going to use dt. It's not always, but generally the case. So we're going to take the derivative of A cross B. Any thoughts? Basically the product rule. We take derivative of one times together, and then the derivative of the other times the first one. Just restated with the product of that, just using the cross product instead of multiplying it. So what this is the derivative of A with respect to time cross B plus A cross the derivative of B with respect to time. You can see why this is sort of like a product rule. Derivative of one kind of multiplied cross product with the other plus the first one kind of multiplied cross product of the derivative of the second one. Alright, so think of it as like a cross product as the product rule, if you're doing cross product instead of multiplying it, you pretty much got it. Okay? And we will ultimately getting into applications of this, but I'm not going to go through it right now. But that's what it is. Alright. You can also, I mean, if you happen to know, you could just solve this, and then take the derivative of it. It'd be an option. But oftentimes that's not convenient, so you'd rather do this. Okay. So, with the cross product, So to get the sign right with this, here's what let me ask you this. So if I have A cross B equals C, what's B cross A? Is it just C? Yeah, C in the opposite direction. It's minus C. And so the order you do this in will change the sign on the torque. That's what we'll do. And so to get the sign correct, so to get the sign of the torque correct, do it as R cross F. If you do it the other way around, if you do F cross R, it'll all be the same, it's just y'all did the sign we flip on the torque. We're going the wrong direction. Okay? So let's say we had, I'm just going to do this just sort of graphically. Let's say we had some R here. There's R. And we had some force like that. Here's some force. So what direction would you expect this? What direction should this part be going? So it's pivoting here. Okay. So is it going to go around clockwise or counterclockwise? I guess is what I'm asking.
Counterclockwise.
Yeah, it should go counterclockwise. And if we use our right-hand rule, and when you do the right-hand rule, you also want to go the direction. So like you do the right-hand rule, I want to go from R to F. So here's R, there's F. I sort of do it with my hands, pull my fingers from R to F. Okay, so it comes up this way, and so that works great because that means right-hand rule, swing this place going, that's counterclockwise. Fantastic. So it works nicely.